Good morning, everyone, and welcome to today's class. This broadcast is coming from you directly from the snowy north up in Michigan. We're coordinating with the Huntsville, Alabama team. So if you hear sleigh bells or something, that's mainly the deer running out in the yard here. Today what we're going to cover are profile annotation tools. And the agenda for today, to begin with, we're going to discuss what are the profile annotation tools. Then we're going to look at how we use these profile annotation tools. And then we'll look at the 21 selection options available. And I put the number there just because there's so many singular options available. It may not be obvious to you what they are or how they can be used. And then we'll look at how we can set up the profile annotation symbology to meet what we need. We'll use examples of doing collision-free text. And then lastly, and actually throughout, we'll look at workflow scenarios using the profile annotation tools. So what the intention today is if you haven't used the profile annotate tool to its greatest extent in the past, hopefully after today's session you'll have a better feel for it, and you'll see how you could use it. So we're going to take it from the beginner level and take it up through and look at various scenarios where you could use it and apply it. Okay, first off, what is the profile annotation tools, or what are they? Number one, they can be used to annotate horizontal alignment-based existing profile windows. So this is intended to recognize an existing profile window and then put annotations on that we didn't have earlier, and things that we want to get at one way or another. Everything comes together now at the profile window stage. We can extract and annotate surface information, horizontal and vertical alignment information, super elevation information, template information, and even roadway definition information. So it's not just a profile type thing. And the capability is there additionally to compute values comparing surfaces with alignments. Now that's pretty obvious probably, but when you look at it, there's many ways that you can use this tool to do things you can't do very easily in other methods. So we'll look at those scenarios. Using the profile annotation tools can be done prior to roadway modeler. So instead of you having to run the modeler, you can evaluate curve diagrams, you can evaluate your super diagrams, or even your template application down a roadway. Similar to the check roadway reports, you can look at it graphically and see how you've applied. And then after the modeler run, you can combine reports so you can compare cut fill values both with your reports and your profile annotation. And what this does, instead of you having to go back and forth between your reports and profiles, you can see it immediately. Additionally, you can check sight distance values on profiles. And then lastly, and not lastly, but another method is used to evaluate an existing design. So you can have existing alignments and existing DTMs and come in and see how is this thing designed based on what we have. Okay, we're going to talk now for a moment about the 21 selection options available. To begin with, we have horizontal alignment information we can access, and this particularly is stationing, cumulative stationing. Stationing is obvious what that is. You can set an interval, but cumulative stationing could be irregardless of equations or begin and end stations. You can have a cumulative length annotated. You can also annotate the number of intervals you use, as well as the number, if you want to call it, of stations. So an application, for example, on numbers would be how many stakes do we need to go stake this out? And if you're putting a hub and guard stake on each side of the road, you've got event points, you've got key points, you've got all that. Real quick, you can use the station numbers and blast out a number so you can come out and get your materials. We'll also look at how curvature diagrams for horizontals can be reviewed, and then deflection angle diagrams, looking at the deflection angle of the alignments. And all of these I'll demonstrate here in a moment. The next thing we'll look at is super elevation information. and this is where we'll look at the super diagrams. Then we have the can't alignment annotation, where I'm actually not going to run this. I'm running InRoads Suite today, but if you're running in rail and you have can't super or a can't alignment for rail, you can check your can't. And you've got the design speed, which is actually under vertical, but I put it up here with super too because you may evaluate with it there. Under the vertical alignments, the first thing, and let me make one thing clear, when you come back and if you use this PowerPoint and to apply, the things like proposed and grade and distance, all of those are the select by options that we're going to look at. So when I say vertical alignments proposed is an option under the option or the selections. So proposed will actually annotate the elevation of the active vertical. The active vertical has to belong to the horizontal that's active, and that owns the profile window. Then we'll look at grade and distance diagrams where we recognize the active vertical and provide these diagrams. Vertical ordinate, what that will do is come through and it will take the parabolic curves and compare them to the extended grade, so you'll have a difference. Then we'll have site distance annotation, which is where we recognize crest and sag curves. And here's where we're going to go through examples with the grade and distance diagrams and different diagrams and look at the site distance and see how we manipulate it. Then we have vertical cardinal station annotation, which is the obvious key points on vertical, the PVCs, PVTs, all of that. Then vertical alignment, length, and slope. This is where you can come out, and all of these are in tabular form at the bottom, not up on the object itself. So on a running view, we can look at the vertical alignment, length, and slope. And then lastly, we have maximum design speed. On the surface side, basically what we have is existing. It annotates the elevation of the existing surface, or actually that would be the surface that we've got displayed or active. Now here is where it comes together on a combination. The cut fill depth compares the active vertical alignment with the active surface and then can compute elevation differences at whatever interval you specify. The same applies to the fill height, so you can do quick comparisons on your design. And this is what I was saying, you can do this pre-modeler, so you could look at this before you run the modeler and get a good feel for your design. We have a running count on templates, so when we run down a model, we're going to look at how this works. We can recognize the roadway definition that's active, and then we annotate at each station where or what template's applied. And then another neat one is this backbone width. And this recognizes the active roadway definition and the template segments, and then it comes out and annotates the templates as applied per station. So that lets you analyze your modeler run even before you ran your modeler run. Okay, we'll come back to that. Now what we'll do is come over to InRoads. And what we've got here, I haven't loaded anything up. I've just got InRoads running. And most of the time I'm going to run with my right lock on right here. And also this lock right here, the pen and pencil. When you go and experiment with this, make sure you have the pencil form of it on. Because what we're going to do is write graphics to the file, and then we're going to rewrite graphics and rewrite graphics. With a pencil on, it erases what we did before and puts the new stuff out. So we're going to run in that mode. And also I'm running on the 2004 InRoads Suite with Service Pack 1. So the first thing I'm going to do is simply come in here and load up an RWK file. This has my templates, my geometry, my DTMs. So you can see right here, I'll open this up a moment to let you see what we've got. We've got a design DTM, we've got an original model, I've got a geometry file, and in fact I've got several different alignments. My main line is the one I'll do most of our annotation on, and that has, on the main line, it's a standard alignment, it's a very long alignment, and it has 3 verticals associated with it. We're going to start out and take a look at our horizontal first. And what I'm going to do first is show you the entire horizontal. So when I fit this, you can see a long horizontal alignment right here. In fact, let me get the right alignment active. That would help. Set active, and I'll just do a view from right here. That was one of the other alignments I have in here for control. But here's the entire alignment. That's the horizontal alignment right there. And I'll do a quick review on that to let you see the size. And what we've got is a main line, and it begins at station 10 and then ends at 431. So let me go back up. No, actually begins at 59 plus 00. So it's a good long alignment. And now what I want to do, though, is work just in a certain area. So we're going to take a look at where we want to work. If I've got this big alignment and then my client says, well, put in a road in the area where we have the surface already created. So if that's my requirement, I'll come over here to this original, and I'll come over and say, okay, well, let me see where the surface is. So when I display that, I can see it's only in a certain area up here. All right. Now, to confirm stationing, I'll just do a quick tracking on that. So I'll come in and say track, and I can come in and I see I'm at about 194. And what we'll actually do is run it at about 200 right there up to about 306. So y'all can see the station. So we're going to run from there to there. And what our issue will be is to profile that and analyze our design and all the different things that come before we model it. Okay? So we've got that information in place. We see where it's at. Now what I want to do now, I'm going to erase everything. I did that just to show you the overall context. Now what I want to do is start analyzing my horizontal and my vertical design. And the way I'm going to do that to start with, I'm going to go to View Geometry, and I'm going to go to 3D Alignment. Now what I've got here, I've got several different verticals. I've got a main line, the left edge of pavement, and a right inside edge of pavement. So I'm going to take the left edge of pavement with my main line, but I want to only run it through the stations I just said. So from 200 to 306. So 200 to 306, station limit. And the reason I'm using this View 3D is I want to have a 3D space representation of my vertical and my horizontal combined, and I'll show how we use that. So I'm going to also put on the cardinal points. That would be like the tangent, the spirals, curve, the spirals, PCs, PVCs, all of that. So we'll write that to the file. And what we have right now then is a 3D representation of that station range. So I'll fit that. That's in top view at the moment. We'll spin in a moment. Okay, the next thing I want to look at for a moment is the stationing of that. So we'll come over here and we'll view stationing. And what I'm doing is I'm getting set up, and I'll start with just close here so you can see that I'm near 200. And you can see right here I'm at nearly 306, just close even like that. I'm going to set it at an even 200 and a 306. And I'm doing this, I'm staging myself so I can do all these analyses because I use a top view and I use a profile view to do what I'm about to do. So I'll run that at that range, and I've got a setup that I want to see already set. And all it is it's got my event points and my cardinal points. So if I come in and take a look, I can see like station equations or key event points, PTs, all the key things like this. So here are some event points. You can see they're defined. Zero offset, our PI, and then we come through, and then some more key event points and a PT. And those actually were done so when modeler runs, key stations have information dropped at them, okay? So when we look at that, and then we can see our curve to the right and the information on that. We've got this in place now. Now, just for a moment, I'm going to look at it in a dynamic. So when I spin this up, what I will see is a 3D representation of this alignment. The stationing's all on one elevation, but you can see we have a 3D representation in space now of this alignment, okay? So I've got that in place. I'm going to fit that, but see, from top view, I mean, it makes no difference when you look at it versus if you just displayed active alignment. So I could have displayed active horizontal, but what I'm doing, I didn't want to. All right, so we've got that in place. Now we're going to take a moment back to geometry, and I'm going to take a look in here at my main line vertical for a moment. When I review the main line vertical, I can see here I've got true elevations. You can see numbers to 300 range, and it's got tangent grades, K values, all that type stuff. So we've got all that information on the main line. That's a true, now this is actually for a divided highway roadway design. The main line was at the median. Now on the edges of pavement, if I go left inside edge of pavement, notice the elevations aren't in true elevation. These are elevation differences, also known as vertical difference alignments. So when I look at these are vertical diffs, and they parallel the profile grade line. If it's at 0, that means the same as the PGL. If it's at minus 0.4, then it's 0.4 units below the PGL from that station range. And I've got the same thing on the right edge of pavement. So you can see the way we control the divided highway. I bring this to you because when we analyze verticals, we're not going to want to analyze vertical diff type alignments, but I'll show you how we can. So we've got the verticals, we've got the horizontal, you can see what that is. At this stage, what I'm going to do, and you might say, well, we took a lot right there, but it's always best to get the most you can in plan so you have a good feel, and then we'll move to the profile. One other thing I want to do in the plan, I'm going to come back to view geometry, and there's another nice little tool called vertical change in plan. If you haven't used this, this is a very handy tool. What this will do is it will let you come in and specify what you want to annotate. For example, I want the PVI station grade or elevation, and I want the incoming and outgoing grades. That's what I'm going to annotate in plan view. So I'm going to set a station range on that, and I'll run it through this same series. And we'll have it here in just a moment. Okay, so when I apply on that, what I've got now is annotation where I can look at my incoming grade and then my outgoing grade, the station of the PVI, and the elevation. And in fact, it's got a couple little sketches on here that are at grade relative to the alignment. So if I slide up, we can see right here we've got the 0.68, and then we jump up to a 2.24, and we've got the information. If you want a K value or length or whatever, you just activate that also. But what we have now then is a quick analysis in plan view of the stationing of all the horizontal and the vertical design. Okay, so we're going to use this and go back and forth now. So from this stage, I'll come over and create a profile. At the profile point, I want the two surfaces that will run from a divided highway design. I'm not going to run any drainage, so we'll leave that off. And I'm not concerned with features in this run. What I will run is a station range, so I'm going to run from 200 to 306 because I mainly want to investigate that one area that I've showed you before. So we'll run with that. And one other thing I'm going to do is I'll set my options. Now here I'm running off the global scale factors. I'm going to leave that set to 2. And that should look all right. And we'll put a profile window right there. So that profile window, if you look at the controls, ran from 200 to 306. Now let me say this. By setting the profile window at the size I want to run, it just makes it a whole lot easier to do what I'm about to do. So there you can see 200, and we'll fit over here on the 306. And I'm going to give the system a second to catch up just in case it's not. Normally we run with a slave monitor and watch that. I don't have it right this second. Okay, what we'll look at now, we're going to come in here and we'll just display the active vertical here. So we'll sit right here and we'll come down to main line, right click, and we'll say view. And then you can see right here where the vertical comes across. So here's our vertical. And at this stage, you may use the vertical annotation and all that. That's not what this class is about. But what you generally do at that point is you come in and use the vertical annotation and annotate curves and everything according to what you want to see. Now what we're discussing in this session is how we use what's called, again, profile annotation tools. And that's particularly actually going to come from one set of tools. All right, what I'm going to do now is go to Profile and Annotate Profile. And these are the general commands we're going to use. Now when I do this, I'm going to be back and forth in my plan, and I want to get the real estate of my screen. So I'm going to simply come up here, left data mouse, and then hit contract, and it slides up my dialog box so I don't have to have it in my way. All right, so I'm going to sit here with the annotate profile, and I'm going to slide it over just a little bit so we can see where we're at. And the way I thought would be the best to start out here would be, I'm going to start with none and just step through each one for a moment to explain it, and then we'll look at combinations, how you can apply these in combination. So we'll start out with stationing. Okay, the station value, when we come across, you can set the size and everything, the format that you want your stationing, the position relative to where it places things, and also if you want to drop equation names, here you can do it. So you don't have to come in and modify your alignment to drop equations. You can do it at this stage and just drop the equation names. Here, station, that's what goes on as a title as we execute this. And let me go over here for a moment. On the frame, there's a start offset. I'm going to I'll leave it at 80 to start with so you can see it. You have the direction up or down that these frames go. So when we come down, what you will see is the annotation coming. The other thing is the separation of the frames. This is where you can come in and separate so you can get your annotation to look the way you want it. And that's a key right there. So we've got that. I'll come back to collision-free text. In fact, I'm going to leave it where it does collide. And the symbology is where, just real quickly I'll touch on it, where I've got this thing set with a font, the color, the weight, the height, and the width. Now normally I recommend using this thing set for a 1 to 100 type thing, or I mean a 1 multiplier. This set of preferences was set up for a 50 scale. So as I blow this up, if I go 2, then that's a 100 scale. So these numbers are large because they were already set up that way, and I didn't want to reset up all the preferences in the Civil INI, so I left them like that. That's why I use a factor 2. That's a 100 scale. If you go back and set these up so you apply a multiplier, then you just change the global scale factor. So nothing changes there. Nothing in all our past lectures changes. It's just the global scale factor applied here is 2 instead of 100. So I've got that set, and we'll come over here for a moment. So what we have on here is station, and we can tell it on the face which vertical to use when we get into vertical, what surface is active, and what roadway library is also active when we go through here, okay, when we look at different options. And here also I can specify the events, like the horizontal and the vertical events. This is where I can turn them on. And so when I hit apply, immediately we get annotation at every 50 units down this corridor. And let me just move it up to 100 for a moment so you can see this. So you see we start at 200, 200 plus 50. If I do that, because of the pencil setting, it erased the graphics and put the text back, okay? Let me put it down to 50 because I want to have some conflicts here. Okay, I'm set at 50, and now I'm going to zoom in just a little bit. So as I come across, I'll just scroll across. Okay, right there, I've already got a couple conflicts on text. What we'll look at right now, we'll go back here. I'll have to expand again for a moment, and I'll extract my profile annotation. And what I want to do here is come over to frame text. On frame text, there's an option. I can set up a collision-free text tolerance. So based on this size or this measurement, we can come in and look at this text. If it collides within that tolerance, then we can do something about it. Now, the way we've got this broken down is that we've got one button that covers all of stationing, cumulative stationing, delta stationing, all of the things you see right here. If we want to independently come over and affect the horizontal and vertical cardinal type stations and sight distance, we can do that, and these won't be adjusted. So each of these are for collision-free text, and based on what you want to have collision-free, that's what you check on. Now, in this instance, all I'm doing is stationing, right? So all I need to do is hit stationing. When I hit stationing and I look back at main, station's still active. If I hit apply, Notice right here, 207 and the 208, when I hit apply, it should spread it. Now, if it didn't spread it enough, but you did see it spread it some. Well, what happens there is I need to come back and evaluate and re-execute, and maybe I need to be a little bit bigger on that. Actually, I think I do. And give me 1 second here. We'll set this up to 15, and let me move that back to 20. Okay, there, now we can see. Now, the reason I had to do that is actually, as I was setting this up, I had it set to 1 to 50 scale. So I set it up now on collision free for a 1 to 100. And you can see right here, with that on, we have no collision. Let me turn it off. We have collision. Okay, well, maybe you'd say, well, that's fine, but when you do that, I don't know where the stations are now. Let me slide up a little bit. Move that out of the way a little. Okay, you can see where we've got collision at the moment. I can now come up here and specify display leader lines. Now when I do that and hit apply, notice it tries to point it at the station, and if I follow it up, it comes up to the point that it actually hits. So when I come back down, you see how it did the breakaway. Now this balance mode stuff, what this is about is which way do you balance? In other words, which way does the leader fly? I'll just use a little example. If it was set to neutral, with 2 it's not going to make the difference. But with a scattering of many, neutral would start in the middle and work its way out. Whereas a positive could start at the high and work down, everything bends one way. So here you can control the way you annotate in the look and feel. You notice positive now moved it up station and bent it. If I set it back to negative and hit apply, it moves it down where it bends. And like I said, you can experiment with this, but this is very nice because immediately we eliminate our collision, as you can see right here. So if you haven't used this in the past, I highly recommend it. I won't get into all the items here, but you can specify how you want this to touch the leader lines. You can specify offsets so they can touch it exact if you want. Whichever way you want to operate, you can operate. So there's a quick example of collision. And now I'm going to come over here and get in a little bit closer again. And just for the sake of not so much annotation, I'm going to turn the leader off, and I'm going to leave collision on. We'll come back here now to selections, and let's take station off. We'll remove it, and now let's look at cumulative station for a moment. When I do cumulative station, you see what it does is it starts at 0 plus 0, 0 and works forward cumulatively. Whereas if I turn the station on with it, you see I start at 200. So that's a cumulative addition. And if I move up a hair, you see that's the title that I put on is cumulative station. If you don't like that title back here on selection, what you do is you touch like cumulative station, it makes it active, and you could say C station if you don't want to have all that other text. So if I do that, hit update, and it's just like the templates, you need to hit update. When I hit apply, you notice there what just happened, C station, okay? So when you use this, that update is something that you do want to use as you move things. Now, another thing I'll show while I'm just sitting here, precision. Let me jump that up to 3. And let me do one other thing. I'm going to change the order on station. I'm going to put that at 1, and I'll hit update. Now, notice station moved to the top. Right now, station's annotated below and C station above. Okay? So when I hit apply, station now is above and C station is below. Okay? And actually I didn't do an update, that's why my precision didn't update. But I can do the order change and not have to do an update. With the update, that's where I can change. Here, let me do it one more time. And we'll hit and apply, and now we have the 3 decimal. But the other thing to be aware of is if I set 3 decimal on that, maybe my spacing doesn't work. So when you set this up, you really need to decide what decimal you're going to use, things like that, before you set up a bunch of offsets. Okay, so we've looked at station and cumulative station. Let me remove cumulative, and let's come in the station interval for a moment. We'll just take a quick look there. And generally, I'll leave station on just as a option so we can look at what's going on. Station delta is the same as cumulative. Well, not the same, I'm sorry. It's looking at the delta lengths between things. So right here, as we get in to different areas, it will show the delta distance between them as we come through, okay? And here I didn't have, yes I did right there, but delta, we may have had one that was just too close. Okay, I've got the station delta. I'm going to come back now, and we'll take that off, remove it, and that was station interval, station number. This one is, again, where the surveyors need to decide from station A to station, well, station 200, you could say, up to station 250. We'll come up there to 250. A little bit further. Okay, station 250. How many bundles of stakes do I need? 116. Now, that's kind of a pain to count all that stuff, and you can easily miss on it. As a guy that's done a lot of this in the field and knowing about bringing out a lot of material, I appreciate this command, because here I can look and see I need 116 whatever it may be at each station. So I can immediately use this tool for that. Okay? So there's a quick example of where you could use the station numbers. All right? Let's come through here again. And I'll put the profile back up. We'll take the station number off. You kind of get the idea there. I'm going to come back to super diagram in a minute. I wanted to, let me see, hit horizontal cardinals. I wanted to hit mainly the alignment, horizontal alignment things before we move to other things. So when I hit an add there and do an apply, what will happen there, you don't see anything right here, but as we come across, then we can see PT station. Now, the thing about this, you see PT station right there. What I'm going to look at is, okay, there's PT. I want to see that up here. In my other top view, I want to look at the station. 20667, okay? And we can look in here, and let me see, that's a point of tangency. And I believe I had some of those, I may not have had that one on. I think I do right there. There's a PC at 216. And what was that, 206? I'm sorry, I'm at the wrong spot. So as I move up here to 206, there it is. I've got the 20667, and you can see it right there. So you can see it in the plan view, and you can also see it down here in the frame. Okay? So we'll come back here on that. I'll just turn that off. All right, so all the time we can be looking at these and we can see the cardinals as we walk down. All right, we'll take the cardinal off, remove it. Now we'll move on to the vertical. We've gone through stationing up through here, and what I'd like to do now is come in on the vertical for a moment. Proposed. What that is you might think that's a proposed surface or whatever. That's over here on the main tab, that is the active vertical alignment, okay? So what I'm going to do here on selection, I'm going to add station and put proposed on. And let's come down and take a look at this. And notice what I'm doing again. I'm using that pencil lock so I can, what you generally are going to want to do is set these up individually, get a feel for them, get them close, and then we start using them in combination, as I'm going to do shortly. So I'm going to set right here, take proposed, I'll come back over here and hit apply. And then here, you can see the elevations. These are true elevations that run down the vertical. Now, if I just sit right here and I flip that to left inside edge of pavement. Now, I showed you at the beginning how those were vertical difference alignments. When I hit apply, what I'd expect is exactly what I see. The minus 0.4s and like that. These are deltas. So if I want to look at the right inside edge of pavement, I hit apply, and there that is, okay? Now, at any time, if I want to, I can come over here, turn on the pen lock, write proposed right there. In fact, I'll do that. Well, I'm not going to do it right now, but I can write it, and then I can go up and put another proposed, for example, below it here on the third one, and it won't erase proposed then. This is a good application of the pen, so that when you put the pen on and then you write, it will leave the data there and let you put it in another place in a moment, okay? So I'm going to leave it back to this, but there's proposed, working off the active vertical. So let's come back over here. We'll take that off. Now just remember this, because this is very important. You can do a lot of things with proposed. A lot of our combined mathematics are based on the active vertical, which we consider on the selection set to be proposed. So I'm going to remove proposed. The next thing I want to look at for a moment is the grade and distance, which is relative to vertical. So I'm going to leave station, and I'm going to do grade and distance. I'm going to come back to main. Here again, I need to make sure I've got the right vertical active when I do this. So when I apply on this, what you'll see right now, in fact, right off the bat, I see I don't like the gapping there. So I'm going to come over to the frame on this, and I'm going to change the offset to 80 right now. This is a good example based on what you combine to how you may have to reevaluate your layout. So you see how I did that and quickly separated. Okay, as I come through also, maybe I want this to be a little bigger diagram. When I'm over here on this frame, the selection of grade and distance, I can set a different height. And just a minute, and starting a different height here. Let me set that to 100. And do an update and apply. And notice how it got bigger. Now, if I just change it and don't update, it's not going to make it any bigger. So let me make that actually 200 even, so you can really see a difference. We'll update it and apply, and then now you can really see how it moved it out. So what we have now, when we come out and look at this diagram, is a diagram that makes sense to me more than that flat one I had a moment ago. So when I come in and look at this, that's the grade and distance. So there's the PVI elevation, and guess what? There's the station. And what also might I put there? I might also put the key vertical information, which I'll come back and do in a moment. But we'll look at this for a moment here. So when we have grade and distance and we come down it, what you see right here, and we look at the top for a moment, we've got our grade and distance running through here. We've got a parabola right here. And what it's doing on the grade, it's going to come in, and it says the slope is 0.48 and the length is 2,500. Well, let's check that, make sure that's for real. So we'll do a quick review. And when we come in here, now see, that's at 6,300. At first I thought I had a mistake. But when I come down here and I look at 200 series, let me back up a minute. We've got the 0.48 exit grade coming out of 193 up to 220. So you can see that 0.48 is what it should be. And for that range, that's what we get, the 2,500. Okay? So then we'll come across a little further. And then when we come in here, we have a curve. So let's look over here at that in the top. Depends if I showed it right. But you can see now where the vertical curve is right here. The yellow being the tangent grade, and now here's the vertical curve coming through. So I can come in and I can see my information. And then I come through again, and I'm sorry, yes, the yellow is the vertical, and the pink is the tangential. So here's my PVI. I can see my information. Now, that doesn't have everything annotated on it, but understand, this thing is distance and grade. This is a distance and grade. So in a few moments, we're going to think about, well, how do I get other things? That's where we talk about combinations. So here we have distance and grade. All right, let's come back. Nice little grade diagram. All right, we're in here, and we'll take distance and grade off. And notice I use station a lot because it lets me see a lot of things going on. We'll take a look at the vertical ordinate. We'll apply on that. And when we look at the vertical ordinate, what that is, let me go up here a minute. As soon as we hit the yellows, that's a parabola. If I slide down, what I have there is the vertical difference from the parabola to the straight grade. Okay, that's the vertical ordinate. So if I fit this, anywhere you see the yellow up in the plan or the profile, I can look down here and I can see the vertical diff. And the reason I did what I did earlier in the game over here on the plan was so that I could take a look here and I could see at 221 that I'm in a parabola and I can see my vertical diffs. I can come over here now and I can go to 221. And right here I know I'm in 221, and then I can see also on the vertical plan and grade what I'm doing. what my strategy was, if it was a sane strategy or not. Because I can look here and say, well, geez, I'm in a horizontal curve and I'm putting in a vertical curve, so I may have some issues. So it gives me an immediate visual feedback. I know that I'm not in a tangent right here doing this curve. I'm in a curve, a horizontal curve doing a vertical curve. So I could be creating problems. And again, that's where the vertical ordinate helped me on my profile diagram. All right, let's go back up here. And like I said to begin with, what I wanted to do is make sure we cover each of these individually, and then we'll turn around and we'll execute the combinations. Okay, so we've got station, we've looked at that, we've looked at vertical ordinate. There's also vertical alignment right here. I'll do an add with that. Now what this one does, it actually, let's fit that, it gives me a vertical diagram. So I can see right here, and maybe that exaggeration isn't enough. It gives me a sag, so you can see a sag curve, grade, sag, and then when I come up here, notice how the curve goes the other way, it's a crest. So I can look at it graphically like that, and being that it's graphical, again, maybe I want to look at it a little bit different. Let me put that up to 200, because I want to look at the graph more than, and I've got to make it active when I do it. That was my fault. So when I update, and notice right here how it looks right now, when we hit apply, then I've got a legitimate curve diagram to look at, and I can look right here in the diagram at what's going on, okay? And also it has the grade and distance, and then the curve information that I had specified displayed right there. So you can look at that, and again, we're combining data to compare and evaluate. We'll take the vertical off now, and we'll come in. There was, I'll just do vertical cardinal for a moment. All the vertical cardinal does is it comes through and it specifies PVC, PVT. You can see how that quickly comes in and annotates on a diagram, okay? But again, it could be of value to you depending on what you're doing. Okay, so we've got that in place, and let's look at sight distance for a moment. And based on our criteria right here, we can set sight distance. So when I apply on that, when we look over here at this crest, we can come in and we can see what the sight distance is. So we have the values right there coming through, and again, we can compare it, and this is where we compare that type of information with diagrams, okay? So you use these in comparison. So what we've done so far is compared the horizontal and the vertical, and then now let's look over here at the super. So we'll look at super, and I'm going to set this down to 50 to begin with, because I don't want it to be exactly right to start with. I'm going to do an update. When I step back from out here and look at it, if I look at that with that 50, I have a hard time telling what's going on, to be honest with you. I can't tell what's going on in that super diagram too well. You can see the transitions and everything, but it's hard to see. So in a super diagram especially, you may want to come in here and blow that up. So I'll do an update right there, and then we blow it up. Now that makes a whole lot more sense. So when I fit that and look at it, I've got a decent looking super diagram. So you can look at your super diagram here and look at your plan right here. Like I said, in a moment, I'll combine all this. So I'm going to take the super diagram off, and you saw what that was. And then we're going to come over here now, and let's look at a curvature diagram. And I could have done this, and I should have done this under horizontal, but I'm going to do it right here, right now. So on the simple curvature diagram, when I hit apply, again, with a small scale, you get, you know, what you ask for. Very small delta. And what this will show you is a horizontal curve diagram with a length and radius reflecting the active horizontal. Now, again, one of these are much better evaluated blown up. So when I do this, let me put that at 500. We'll do an update on that. And when I apply, now we have a diagram that makes a lot more sense to look at. So we can look at this diagram and we can see the radius here, the tangent, then the radius here, And you can see the differences coming through quite nicely. Now we have an option here where if you want to just see where the curves are, you don't want to see the magnitude, you have an option called Make Curve Heights Equal. So make sure you look like this right here. When I hit apply now, with that, and I didn't do an update, I don't think. Curve, do an update. What that did, actually it did, it made these so they're the same length. And the curve height, what it's intended to do is to equalize the radii. It doesn't differentiate based on a radius. So let me update one more time with it off. And then we have a differentiation. Notice here how small that is, and that one's bigger. So you have different sizes based on radius. So if you want to equalize it, you can equalize it. But generally, I would leave that off because I would like to see what I'm working with. Okay, we've been through most of those. Let me come up here now. To go to the top, we've gone through nearly everything curvature existing. All that is on the main over here, the original surface that's active. It's active. I hit apply. I need to add it to the list. So when I hit apply, what it will do is it will come out and it will annotate the information on the active surface. That's how that works. So notice the 38039, if I flip this over to design and hit apply, it's 39000. So it doesn't even have to be applied there or displayed in the window, but what it will do is it lets you activate it and then annotate it. Here again is the perfect example of where the pen and pencil comes in, where if you want that to stay and you want another one below it, you can have it where you write that in pen and then come down and write another one in pen here, just changing names. That's the pen and pencil techniques. Let's remove existing. And proposed was the active vertical, you all know that. Now cut depth, let's look at that. Cut depth takes the surface specified right here and compares it to the vertical right here, okay? That's period, that's what it does. So when I hit apply, now notice right here, it didn't have a number right there, it's 352, okay? But that's based on that vertical. If I change that to left inside edge of pavement, remember, those are deltas and they're real low. They're huge numbers right now because that's a elevation difference surface. So I got what I asked for, which is not what I normally want, but that shows you how you could do that. So then when I apply, it puts it back right. So what this does, when we fit and take a look, you can see anywhere where cuts were, just at a glance. So I can see that. I'm going to come back up here, go back to selection. I'll take the cut off, remove it, and then I'll say I want the same on the fill. Show me the fill based on active vertical and active surface. Or I should say whatever's active in this dialog. So when I hit apply, it changes it to fill height, and now I can see the fill relationships. So again, immediate feedback. It lets me, again, I'll fit, and I can see where all the fill is along here. So I could check my reports against that and see if I'm doing what I expect that I'm doing. So that's a handy tool. And let's go back to selection. We'll remove the fill. So we've looked at that. One other one on horizontal is the deflection. Now what this will do is it will run through and it will put this is a straight line diagram essentially, but it will put out there the delta angle on the curve. So if I come in here, that's at 205. If I come in at station at about 205, if I review at 205, come up a second here. I see 1132.53. I see 1132.53, and I've got precision to 2 decimal seconds. So what that does is it lets me, in a longitudinal view, check the delta angles on the plan view. Again, a nice handy tool. And again, everything is relative, so you have to decide what do I want to use and where. A second, let me get that fit. Okay, we're almost there. A lot of stuff to show with this. It's a very fun tool to use. That was deflection, grade and distance, and that elevate or vertical we've looked at. Now template. Let me get back to template. We'll add template. This is based on the roadway definition used right here. So if I use mainline 4 and hit apply, I've got mainline template. Let me zoom into that so you can see it. Mainline with turns. Okay, that's the name of it. If I look at my roadway definition for a moment, and I look at mainline 4 and look at it, it's mainline with turns. That's what it is, okay? And it actually runs the whole length, mainline with turns. So when I do a fit here, there better not be another one or I did something wrong. Okay, there you can see it from a far-out view right there, and then you see it at the end, and that means from the beginning to the end, run mainline with turns. Now, I'm going to leave it zoomed out here a little bit and show you what happens when you bring in a more complex one. If I flip this over right here to mainline complex and hit apply, what will happen then is you can see I've got more transitions coming, okay? And so it will come through and it lists, and I'll just do a fit here, it lists my more complex transitions. And so I transitioned a bunch here, and then I went the rest of the way with the same settings. So that's a mainline transition look. Okay, and then that, again, without even running modeler, I can look at that. So that's very handy instead of just running the report. So I'll take template off, we'll remove it. Now another neat one right here is backbone width. Let me get the right one, backbone width. Now what this will do is it will show me graphically what I think I'm doing. Now understand if I'm running H and V control that could be overridden. But if I'm running rigid template, this will show me the background literally. So as I run through here, I can see the different widths. In fact, I don't have this set exactly up, but it will show you here width left and width right. So you can have them, and here I've got just a little collision. If you do that, the one thing is all this is graphic grouped. So when I come back again and try to move it, there, we can move it. It depends on how many, the copy is why that didn't quite go right. Let's do that one more time, but this time we'll do a move. There's a move so you can see left and you can see right. This is a very handy tool to let you analyze design. And again, I'm going to stay zoomed in here. If I change it back to that, hit apply, then it updates based on the active design. So that, instead of me running modeler over and over, I look at it quickly. Okay, let's bring our tool back up. Annotate profile, and we've been through, I believe, all the different commands or options. I haven't run cant or speed, but I did not intend to. Okay, now let's talk about this in combination. In fact, let me step back to my slide just for a moment. We have looked at text settings. All this information stored in the civil INI. The commands do obey the factors, and it also recognizes the preferred preference name, so you can set a preferred as you go instead of flipping them or whatever. And framing is based on the order of annotation, and you can do a lot of control with that. And the collision, you can see you have many ways to control that. We've gone through it. And then workflow scenarios, briefly, because I've got about 2.5 minutes I'm going to run yet. You got that, Wes? And this is where we can evaluate horizontals, we can evaluate verticals, evaluate supers, we can check cut and fill, and we can synchronize horizontals to verticals to supers to sight distance. So I'm going to come back very rapidly now, and I'm going to do a none, and I'm going to do a horizontal comparison. I'm going to say check the station. I want to check the super next. On the super, I've already got it set. I want to look at the curvature diagram. And in fact, due to my, yes, we'll run it at that. Just a second. I want to see a deflection diagram. And if there's anything else, I think, and we'll take the horizontal cardinals. So when I execute that, what happens is I have the information I want to look at my horizontal. Now, what I probably want to do is look at my vertical also. In fact, I might say the deflection doesn't give me anything, so let's take that deflection off. All right, so I've got my station, my super, my curvature, my horizontal. Now I want to come down and I want to look at a distance grade, and I want to look at the vertical alignment, okay? So when I execute that, now I can look at it. I have my stationing, I have my super, I have a horizontal curve diagram, I have a grade diagram, and then I have a vertical alignment diagram below it. So these may tell me quite a bit. Now, when it's said and done, I may want to see that backbone width also down there. Oh, I didn't add it. So when I apply, then I can look at my model and see, oh, that was the wrong alignment. I'll set it to the complex, and then I can see what I'm doing right here. And maybe I need to look just a little better at that backbone. I need to blow that up to 500 also. So I'm setting my visual aids up for review, and now I can look at it. And this is what I'm running. Does that help me analyze my design? I think it does. And then lastly, I could just do a sanity check on cut and fill. So I've got the cut depth, and then I'm going to put the fill depth in. I'm going to come over to main, make sure I have the right alignments and surface active. So when I hit apply, what I've just done is I've come over here and I've run my math functions. I've looked at all my diagrams, and anything I need to change now, I've got both the top view and I've got a plan view. And so if I modify here, I can update here. If I modify here, I can update there. So when it's all said and done, we've just gone through the profile annotation tools. In conclusion, the profile tools are very powerful, possible to analyze many aspects of the design with the profile annotation tools, and complex workflows can be accomplished with these tools. So this concludes today's session on profile annotation.